Management metrics, assessing management impact and effectiveness. When we set the stage at the beginning of the book, we emphasized network management's business significance as a primary motivation and driver for network management technology. In this final chapter, we return to the business proposition of network management to close the circle, so to speak. Specifically, we take a look at how the impact of network management can be assessed and how such an assessment might be methodically approached. Of course, the more effective management is, the greater its impact will potentially be. Therefore, we also discuss how to assess management effectiveness. Assessing the effectiveness and impact of network management is important in a number of ways. For example, it helps in deciding where to direct investment into network management technology and which specific aspects to tackle first. It provides a basis for developing return on investment or ROI models that help evaluate where such investment will have the biggest impact and whether it will even be justified from a business perspective. This is relevant not just for users of management technology, such as IT departments and service providers that operate networks, but also to developers of management technology, such as system integrators, equipment vendors, and management application software vendors. It allows them to assess where their development efforts will deliver the biggest bang for the buck. Also, although this is a technical book, a good understanding of the impact that technical choices have on the related business does matter, even from a technical perspective. After reading this chapter, you will be able to do the following. Number 1. Articulate the ways in which network management has a business impact. Number 2. Understand factors that impact management effectiveness. Number 3. Use metrics to quantify network management value propositions and measure the effectiveness of a network management technology and organization. Number 4. Develop and apply metrics to help you evaluate technical alternatives and assess progress in management effectiveness over time. Network management business impact. Network management is a competitive factor in a number of ways. Network management affects the following: the total cost of ownership or TCO of a network, revenues that can be generated from communication services, certain properties of the network itself that increase its value, most importantly, network availability. We quickly review these three aspects before getting into factors that influence them and metrics to assess them. Most obviously, network management affects the operational expense of running a network. An effective operations support organization, coupled with an effective operations support infrastructure, facilitates the job of the operations staff, allowing the staff to do more with less, increase its responsiveness, and potentially reduce the need for hard-to-find skills and training. Very importantly, network management also affects the required investment in the network itself. Proper management tools can help plan a network and provision a network so that it becomes better utilized. This avoids dimensioning the network to a size that is larger than is required to meet service level objectives and helps to squeeze more out of each network investment dollar. Other cost effects are more subtle. For example, using service level monitoring capabilities verifies the level of service that is received from other service providers. This can lead to the recovery of cost when service level objectives are violated. More important, the threat of verifying the service level that is delivered can lead to a better service being provided in the first place. Another example of a subtle cost effect is associated with the capability to monitor communication resource consumption in an enterprise. When users or user groups are confronted with their communication service consumption, for example, by letting them know when they are a top talker, internal ways of communication services can be discouraged. Enabling of revenues. Less obvious, but just as important as the cost side of the equation is the fact that network management is also a big factor in increasing revenues that can be generated from a network investment. This occurs in a number of ways. Perhaps most important, network management can accelerate service rollout, the speed at which new services can be introduced over a network, and the speed at which they can be deployed. Service provisioning systems have a big role to play here. Obviously, the faster a rollout of services occurs, the sooner customers can be charged and revenues can be collected. An intangible side benefit of swift service rollout lies in creating the appearance of crisp responsiveness, which helps build confidence in the product with the customer. By the same token, network management can help avoid revenue loss from inadequate network planning and dimensioning that impedes service rollout. As many companies can tell, few scenarios are worse than having a product that customers want but not being able to deliver. Proper network management tools for planning and statistics collection and analysis can decrease the likelihood of network provider organizations finding themselves in such situations. Network management can also impact how much can be charged for a service. For example, with proper service level management in place, a service provider might feel confident guaranteeing higher service level objectives, for which it can then charge more. At a minimum, it provides a competitive advantage over competitors that cannot provide equivalent guarantees. In some cases, network management itself might be a feature of a service that might be charged for at a premium. Examples include the capability to generate a unified bill for multiple services, or providing service statistics for users to access over the web. A famous example concerns the family and friends service plans offered by some telecommunication service providers well over a decade ago. The capability to charge for calls differently depending on who was being called was a service feature that was enabled not by the network but by the billing and accounting systems. In other words, management technology. Customers love this plan, and service providers whose operations support infrastructure offered no comparative capabilities underwent serious struggles to maintain market share. Network availability. Finally, network management plays a significant role in improving certain properties of the network itself that increase the network's effectiveness and value. Of course, it might be argued that this additional value can be translated into additional revenues and hence be subsumed under the previous category, which have discussed a while ago, the enabling of revenues. Nevertheless, this aspect is relevant enough to stand on its own. The most important aspect here concerns network availability. To improve network availability, a network provider might decide to invest in highly available networking equipment at a cost. However, an equivalent or even greater impact on network availability can, in many cases, be achieved by investing in network management instead. Network management plays a significant role in reducing the number of errors that network operators and administrators make and that can lead to unintentional outages. An example is a service that is accidentally, improperly configured, or the application of conflicting configurations to network devices that cause communications to be disrupted. Service provisioning and policy-based management are just two of the many techniques that contribute this way to a network availability. In addition, network management can help reduce the impact that operational errors can have on the network and recover from those errors. During operations, network management plays a major part in being able to spot impending trouble quickly and thereby ideally enables preventive action before problems occur. Performance trending and threshold crossing alerting are examples of techniques that can be applied. Likewise, when failures do occur, network management facilitates quick identification of failure root causes and corrective action. Trading off the benefits and cost of network management investments. Of course, network management's positive impact described previously is partly offset by the cost of network management itself. The cost for additional operational support infrastructure, and to a much lesser extent, the additional management traffic and load on network devices that could otherwise be used for production traffic. Clearly, investment in network management technology needs to be directed in such a way that the incremental return exceeds the incremental cost. This incremental return consists of reductions in operational expense, increases in revenue, and increases in the network's value, which can be translated into some monetary value. In addition to the immediate return, other factors need to be taken into consideration. One such factor concerns the cost of managing the operations support infrastructure itself as the underlying network evolves. This needs to be undertaken into account as also as part of the decision for the network investment itself. A second factor concerns economies of scale. Network management needs for a smaller network are not proportionally less than for a larger network. Of course, the scale is smaller, but the management functions that need to be provided and systems that require investment to support them in many cases might be largely the same as for the larger network. All other factors being equal, the incremental cost of network management should hence be expected to decrease as the scale of the network grows. Again, this could impact investment decisions. An investment that might not be feasible for a smaller network might become more feasible for a larger one because it can be amortized over a larger number of devices, or ports, or instances of end-user services, or whatever measure for network scale is used. Chapter Summary. Network management is done not for its own sake, but to make network systems and communication services run smoothly and efficiently. In the end, as interesting as network management is, as a technology, the drivers behind it boil down to money. Hence, when dealing with network management, it is important to always keep this aspect in mind and understand the business ramifications of management technology. Management technology needs to be effective, which means that it provides tangible benefits for a network provider and delivers a good bang for the buck. In this final chapter, we took a closer look at those aspects. One of the takeaways should be that network management is not just about reducing cost of ownership. It is also about revenues, of course more so for service providers than for enterprise IT departments, about availability, and about getting the most out of your investment in communication services and technology. The effectiveness of management is influenced at every level at which management interactions occur, by the managed devices and systems and how manageable they are, by the operation support infrastructure and management systems and how productive they make their users, and by the management organization itself. Many factors contribute to management's bottom line. To assess the effectiveness of management metrics are needed. Although there is no single established way to measure management in an objective manner, many metrics can be applied, both to measure management's business impacts and to measure the effectiveness of different factors in management that are known to contribute to that impact. In addition to established measures for aspects such as scale and availability, many of the most relevant metrics are custom developed to pertain to the particular context in which management occurs. For example, related to the efficiency of specific management tasks, in the end, such metrics can be used to track efficiency gains over time and to help direct investment as well as technical decisions concerning management technology. The chapter review. In what ways can network management impact a service provider's business? Give an example of a network management technology or feature that can affect revenue. Give an example of a network management technology that can affect availability. At what levels can the effectiveness of network management be assessed? Name the two different contexts in which an elaborate GUI of a management application does very little to increase management effectiveness. Imagine that you have decided to invest in the development of custom rules for your event correlation system. The goal is to improve automated diagnosis of failures in the network. The development can be carried out by one consultant who can incrementally introduce new rules into the system, which will make the system gradually more effective. You decide to give it a try, but you want to make continuation of the project dependent on it, indeed, fulfilling your expectations as you go along. Can you think of some metrics to use to assess whether the system fulfills expectations? Imagine that you need to decide whether to invest in a new service provisioning system. That system is expected to carry a significant price tag, in particular, when taking into account the cost of integrating the new system with the existing operation support infrastructure. What metrics might help you decide whether this is a worthwhile investment, and how will you do the math to arrive at a go, no-go decision? What is the difference between MTBF and availability? Which three aspects determine the complexity of operational tasks? A management application vendor boasts about the scale of its management system, claiming that it can support 10 million managed objects. What are some questions that you might want to ask in return? This is the chapter review. Thank you.
Factors that determine management effectiveness. The effectiveness of management is influenced at multiple levels. At the level of the managed technology itself, this is often also subsumed under the term manageability, referring to the ease with which managed systems and devices allow themselves to be managed. At the level of management applications and operation support infrastructure. Finally, at the level of the management organization itself that uses the tools and infrastructure. The multiple levels of management effectiveness. Shortcomings at one level can often be overcome, at least to a degree at a high level. For example, consider a scenario in which operations support personnel want to be notified whenever utilization on an important link surpasses a critical level. One way to support this function is by configuring a threshold crossing alert for link utilization on the affected equipment. If a managed device does not offer the capability to configure a corresponding threshold crossing alert, a management application on top might resort to polling the device and emulating the threshold alert to make up for the capability. This enables operation support personnel to still be notified when an important threshold is crossed. Letting the management application resort to polling comes at a price. For one, it increases the management load on network and devices. In addition, it decreases the scalability of the management application that now has to perform the polling because effectively complexity is pushed further up to the level of the operation support infrastructure. Managed technology. Manageability refers to the collective set of properties of an entity that allow it to be managed. Those properties can largely be attributed to the entity's management instrumentation, the management interfaces that it exposes, and the capabilities that those interfaces provide. Manageability is not binary in nature. Instead, it represents a continuum that consists of a multitude of different factors that can make management easier or harder. No single factor determines manageability. We begin with manageability factors that affect cost of ownership. Two aspects are associated with cost of ownership: the cost of integrating the managed devices into an operation support environment and the cost of operating and maintaining the device. The cost that is involved with getting managed devices supported by management applications is often also referred to as the integration tax. Higher manageability results in decreased development time and faster time to market of management applications, leading in turn to devices that are more widely supported by management application vendors. Here are examples of how various aspects of manageability can impact the integration tax. Consistency of machine management interfaces facilitates design and code reuse for application development and device integration, and is hence crucial to containing the integration tax. Consistency can be an issue at multiple levels. The consistency of management interfaces across different devices, across different revisions of the same device type, and even across different but related functions of the same device type. In each case, consistency means that the same management feature instrumented in different places works and behaves in the same manner. Adherence to management standards is one technique for ensuring consistency of management interfaces. This is not surprising. The very purpose of management standards is to promote consistency of management interfaces. Reliable events facilitate event-driven design of management applications. They reduce the amount exception handling that management applications must implement to deal with the possibility that important events are missed, and they obviate the need for additional polling mechanisms. Self-management of certain functions reduces their need to be managed in the first place. An example is a capability for device to exchange certain configuration parameters about each other through a mutual handshake instead of needing to have the configuration parameters provisioned by a management application. Introspection capabilities allow applications to obtain information about the management interface and capabilities that are supported by a device without requiring this information to be coded into the application. Such information consists of meta-information, that is, information about information, concerning data revisions, management parameters, and commands supported. Introspection capabilities can thus facilitate data-driven design of management applications that makes maintaining the applications easier. Threshold crossing alerts help management applications avoid the need to implement elaborate polling schemes and make it easier for them to scale. The second aspect of cost of ownership concerns in lowering operational costs. Loosely speaking, this refers to the cost that is required for operations personnel to support networking equipment. Of course, in many cases, operations personnel does not interact with the managed devices directly. Instead, it interacts with management systems in the operations support infrastructure that hide many of the device intricacies. Consistency of management interfaces facilitates the task of network administrators when interacting with the device directly, not through a management application. Consistency reduces training costs and increases the pool of personnel that can manage different pieces of network equipment. Support for management policies allows network managers to configure only a few management policies instead of requiring tuning of many low-level parameters. It might still be possible to override such policies on an individual basis, but chances are the most settings that need to be applied are the same. Admittedly, this is an extremely simple example for a policy, yet one that will clearly make life easier for network managers. Comprehensive diagnostics capabilities allow a network manager to more easily troubleshoot a device or network. Self-management of certain functions reduces the need for management intervention, clearly simplifying life not just for application developers, but for network administrators as well. Everything listed so far relates to lowering the total cost of ownership. However, as previously mentioned, manageability can also impact the revenue side of the equation. Threshold crossing alerts allow early and proactive reaction to performance degradation. This can result in higher service levels and ultimately higher revenues. Comprehensive data collection capabilities in the device to provide detailed data about service levels can be used in accounting and dispute resolution. Support for resource partitioning enables network providers to divide a device into multiple logical devices and might facilitate providing a new types of services altogether, such as virtual router services. Finally, manageability can be a factor that contributes to the availability of networks and services. Manageability features can help reduce the possibility of availability being affected by accidental operational errors. They also help accelerate problem diagnostics and repair to minimize downtime. Increased availability in turn increases customer satisfaction and leads to increased revenues as well. Concurrency support within a device and across devices facilitates coordination between competing management applications. Concurrency support includes the capability of management applications to lock parts of the configuration for their exclusive use. This helps avoid situations that result in inconsistent network configurations and services outages. from multiple management applications that unintentionally conflict with each other. Integrity checksums help avoid outages from corrupted configuration files. An integrity checksum is a number that is completed from the rest of the file contents and then appended to the file. The basic idea is that if the file has been altered, this can be easily recognized because recomputation of the checksum will lead to a different number that does not match the one that was originally appended. Input validation. Syntax and semantic checks before actually attempting command execution helps avoid outages that are caused by invalid commands sent to a device. This is particularly important when there are groups of commands that can be submitted to a device for execution at the same time. Rollback capabilities allow managed devices to automatically fall back to the last known working configuration in case of a configuration error. This allows devices to recover from errors that were not caught or avoided by other means. Self-management capabilities decrease the dependency on external network managers and management applications, which also avoids operational errors and untimely management actions that could affect availability. And again, threshold crossing alerts allow early reaction to degradation of performance before availability is impacted. In many cases, the same manageability features contribute simultaneously to several goals. For example, support for threshold crossing alerts affects not just operational costs, but also the capability to generate revenue as well as network availability. Management systems and operations support infrastructure. We now take a look at management applications and identify what types of properties affects management effectiveness at that level. As we did in the case of manageability, we turn to the cost side of the equation first. It must be recognized that management systems are themselves a cost factor, even if that cost is more than offset by the benefits they provide. The following are some of the aspects that affect the cost associated with management infrastructure, most of them completely unsurprising and in line with that of other business software applications. The capability of a management application to scale. Management applications that scale well might reduce the number of hosts that are required as part of the operational support infrastructure. This lowers the secondary cost of needing to manage that operations support infrastructure itself. Management applications that scale well also facilitate build-out of the network itself because this build-out is less hampered by issues relating to the capability of the operations support infrastructure to keep up. The capability of a management applications to be distributed across multiple hosts. This can be one cost-effective way of allowing applications to scale because it is possible to simply add hosts instead of needing to upgrade to a larger and potentially much more expensive host. Use of low-cost operating systems, hardware platforms, and databases. Capabilities that facilitate management of management systems themselves. It is important that the task to manage the operations support infrastructure does not unduly distract from the management of the production network. Features that facilitate integration into operations support environment. Perhaps most important, this includes support of 4 comprehensive northbound interfaces, properties that those interfaces should possess to facilitate an application's integrations with other systems largely mirror those of management interfaces of the managed devices themselves. The capability of a management system to integrate with different systems can simplify workflows and avoid the need to enter and maintain redundant data. Productive user interfaces can help network managers accomplish more. One aspect to consider is that in many cases, the productivity of an interface depends on the target user. Occasional users require interfaces that are easy to learn and understand, often relying on drop-down menus, GUI wizards, and elaborate graphical displays. Power users, on the other hand, might find the same interfaces slow them down, preferring interfaces that are more character-based and that offer plenty of keyboard shortcuts. Programmability and customization of management functions enables network managers to automate routine management tasks. Features that assist users to sift through large volumes of management information enables management by exception and further increases productivity of network managers. Examples of such features include this: visual highlighting of information that seems out of the ordinary just in the case of manageability. Management applications are not only about reducing operational costs, there are also ways in which management applications features can help increase revenue. One technique to improve provisioning throughput is to support concurrent communications with multiple devices, which allows the provisioning applications to direct provisioning requests at multiple devices simultaneously instead of having to serialize requests. In addition, in some cases, network management can itself be a service feature that a service provider might be able to charge for. A service provider might offer facilities that allow customers to provision certain aspects of their service. For example, to add bandwidth to a link in a virtual private network in a self-service fashion. Such capabilities are sometimes marketed using labels such customer network management. Finally, many management systems features can help increase a network robustness and availability. In fact, this is one of the very purposes of many network management applications, such as fault management applications. However, other examples apply to a much wider range of management systems. For example, checkpointing, audit logs, backup, and restore functions allow management systems to more quickly recover from failures. In addition, management systems can perform a significant number of syntax and semantic checks before sending requests to managed devices, thereby decreasing the chance of introducing inconsistent network configurations. Functions to sort, search, and filter information according to a wide variety of criteria. Graphical representation of large datasets, for example, through diagrams, curves, to visualize trends, and the like.
Management Organization. This is a book on network management technology. We focus on the effectiveness of the technology, not on the management organization itself. Of course, effectiveness of the management organization that uses management technology is an equally important factor in the running of the network. Here, lessons of general organizational effectiveness apply. Providing services and operating networks constitutes one particular scenario to which methodologies developed in its space can be applied. One example of such a methodology is the balanced scorecard. This methodology suggests viewing the organization from four distinct perspectives: learning and growth, business process, customer, financial and developing metrics, collecting data, and analyzing the organization with respect to each of the perspectives. A second example is the performance prism, a methodology that focuses more on optimizing organizational effectiveness than assessing it. The performance prism distinguishes among 5 perspectives: stakeholder satisfaction, identifying the stakeholders and what they want; strategies, satisfying the stakeholders; processes, executing the strategies; capabilities, supporting the processes; and stakeholder contribution, helping develop and maintain the capabilities. It is interesting to observe that this is the blind man and the elephant. All over again, one aspect that many of those methodologies have in common is that they all identify a set of different dimensions that are used to characterize the problem of space. Of course, there's no single way to assess organizational effectiveness, but there are multiple ways to skin the cat. Accordingly, different methodologies come up with different ways to divide and conquer the problem. Assessing network management effectiveness. Now that we have reviewed the factors and management features that contribute to management business impact, how can we actually assess how well management is working? What is needed is a set of metrics by which the effectiveness of the management can be measured. An understanding of such metrics, along with an understanding of the different ways in which management technology contributes to those metrics, can provide invaluable guidance for determining priorities in the development and deployment of management technology. Ultimately, what counts is the bottom line. Hence, metrics used for network management should include the same type of metrics that would use for any other type of business. We therefore start by taking a look at some metrics that capture business impact. As we shall see, those metrics alone cannot capture the entire picture. They need to be augmented by other metrics that capture how effective various factors that are contribute to the bottom line. That aspect is discussed later in the chapter. In effect, there is a management value chain. This chain starts with an individual management features, such as threshold crossing alerts, programmability, and sort and search functions. As discussed previously, those features contribute to various factors in management effectiveness, such as user productivity, operational robustness, and scalability of operations. Management metrics to track business impact. As mentioned earlier, the business impact of a network management consists of its contribution to cost savings, revenues, and improved network services themselves, especially regarding reliability and availability. We start with metrics that can be applied to assessing the cost side of the equation. The metrics that are presented here do not constitute a complete list. Instead, they are intended to provide a sense of the areas on which management has an impact and how this impact can possibly be captured. For one, there is a total cost of the operations. This includes the cost of the operations staff and the amortization of cost of the operation support infrastructures. The more effective the management, the lower the total cost. Of course, total numbers can be hard to compare because the total cost does not take into account the complexity and scale of the network being managed. Normalized metrics that put the cost into perspective regarding what is actually being achieved are often more meaningful. For example, total cost of operations can be normalized over the following: number of devices, operational cost per device. Because devices can be vastly different in nature and scale, this metric is not always meaningful unless dealing with very homogeneous environments. Number of ports, operational cost per supported access port. This provides a more level playing field and allows operational costs to be compared across different types of equipment. For example, these measures should reflect better economies of scale if large-scale pieces of equipment are used. Such equipment will likely involve a higher operational cost per device. However, taking into account the additional capacity paints a more appropriate and favorable picture. Number of service instances. For example, operational cost per voice extension. Number of end users. For example, the operational cost per employee in an enterprise. Other metrics track the contribution of individual cost factors. An obvious set of metrics concerns operator productivity, measuring the number of devices, ports, service instances, or end users that single network operator can support. A variation of this is the amount of service revenue supported per operator. Another example concerns the number of truck rolls. For example, truck rolls per service activation or truck rolls per year of maintaining an already activated service. Truck rolls refer to the need to send personnel to a customer, in many cases, driving in a truck, to activate and maintain a communication service. Not only are truck rolls very expensive, but they also inconvenience customer and negatively impact customer satisfaction. A third example concerns the number of customer calls to a help desk that are required to resolve a case. Clearly, the number of calls should be as low as possible because each call costs money and inconveniences customers. Sometimes, the ratio between different cost factors can provide useful information as well. A telling metric in the regard concerns the ratio of the operation support infrastructure amortization cost to personnel cost. A high ratio could be an indication that there is a high build out of operation support infrastructure, leading to potentially diminished returns on the further investment in that area. A low ratio, on the other hand, could be an indication that investment is too low and that operators could be better leveraged by filling up infrastructure, particularly if the normalized cost of the operation is relatively high. There are also metrics concerning a network management impact on our revenue. The problem between many of those metrics is that although management is a contributing factor, how much revenue can really be attributed to management is not always clear. In many cases, there are also many other factors at work. Nevertheless, there are metrics that are still useful, such as the following. Mean time to fill customer orders. Time from service order to service activation. The shorter the time, the better because the revenue potential of a service is more fully exploited. Average size of the customer order backlog. Again, this number can be translated directly to customer dollars. The smaller the average backlog size, the better. Customer defections from slow order fulfillment. Services cancelled and hence revenue loss from the customer canceling services before they were activated. Total penalties for service level agreement violations, reflecting to total lost revenue. Ratio between penalties and theoretical service revenue, reflecting the portion of revenue that was lost from violated SLAs. Finally, reliability and availability of the network and the services need to be assessed. The classical metrics here are the following. MTTR, mean time to repair. Another classical measure, this indicates how long it takes for services that are impacted by failures to be restored. Of course, for all these metrics, a question needs to be asked. Availability, MTBF, MTTR, of what? The metrics can be applied to individual services in a network and to the service as a whole. However, it is quite clear what counts from the perspective of the customer. That customer service, it is important to realize that availability of a service and of a device in the network that carries the service are not the same. The good news is that service availability can be much higher than availability of the network or network devices. For example, when a device fails, services might automatically be switched over to other services in the network. Nevertheless, it is also availability of the network equipment could ultimately affect services as well. In addition, it leads to negative impacts on operational costs because failures must be dealt with it. As with many of the other metrics, it often makes sense to further differentiate these metrics and distinguish between different types of devices, different types of the services, different geological regions, and different domains of the responsibility between organizational subgroups. This can be a data for interesting comparative evaluations. For example, if one of the group in the organization consistently scores higher on certain management metrics, it might be possible to learn important lessons from that group and apply them to the other parts of the organization. Finally, in the eyes of the customer, maintenance is another factor that impacts availability. Needing to account for maintenance operation is an inconvenience, although of course, it is by far preferable to unexpected services outages. One meaningful metric with regard to the effectiveness of the maintenance is the ratio between unplanned outages and scheduled maintenance intervals for services and for managed devices. Clearly, this ratio should be as close to zero as possible. Another metric is mean time to maintenance. Although the ratio between unplanned outages and scheduled maintenance intervals might be improved simply by increasing the number of the maintenance intervals, doing so would come to the expense of this metric. In addition to being a factor in availability, how often maintenance needs to be performed is a factor. Management metrics that track contribution to management effectiveness. Metrics that can be used to assess management business impacts are one way to assess management effectiveness. However, those metrics do not tell the entire story. Many factors impact management effectiveness, each of which is the result of the combination of the features. For example, some features of management application make networks managers more productive. Other features improve operational robustness by making it harder for network managers to introduce inconsistent configurations. The operational equipment of shooting themselves in the fleet. An important question, therefore, concerns whether it is possible to assess the individual contribution of each of those features to management effectiveness. Although the metrics that have so far been discussed allows assessment of the impact that management features collectively have, they provide no indication of their individual effectiveness. In some cases, it is possible to do better. It is the topic of the following discussion. Metrics for complexity of operational tasks. Perhaps the most important aspect of the contributes to management effectiveness concerns the complexity of the operational tasks that the network managers are faced with. Reducing complexity is important for a number of reasons. It reduces operational costs because the operators generally have fewer steps to perform a given task, and those steps may be simpler, requiring less training. It allows the completion of more the same task in the same time, thereby increasing operational true output. It reduces the opportunity to introduce errors, which might impact availability and demand complicated recovery. The management metrics that we have encountered far allow us to see the impact of complexity on business. However, they do not allow us to assess complexity directly. Complexity of operational tasks can be assessed in a number of ways, many of which were first articulated in a paper by Brown, Keller, and Hellerstein that was published at the IM 2005 conference. This conference is listed in Appendix B for the reading. Three different categories of complexity are distinguished. Execution complexity consists of two aspects: the number of steps that the task involves, the number of context switches involved in a task. Roughly, this reflects how many different targets, for example, different pieces of networking equipment or different types of device interfaces the steps are directed at. Parameter complexity concerns the complexity of the parameters that are required as part of each step. This complexity is determined by several aspects, including the following: the number of the different parameters that are required for all steps in total, the average number of parameters that are required in a step. Some parameters are required in more than one step. The ease which a network manager can obtain these parameters value for each parameter, a corresponding score is assigned. A high score is applied when a parameter represents an obscure value that requires a good deal of experience to choose. A low score is applied for parameters that are obvious, or that required only a simple lookup. Scores for all parameters are aggregated. Memory complexity concerns the amount of the memory that is required in the mind of the network manager to perform the steps. It takes into account the number of the parameters that must be remembered, the length of the time they must be retained in the memory, and how many intervening times were stored in the memory between uses of the remembered parameters. Memory complexity can be expressed with a large depth of stack that would be required to hold the required items. To obtain management metrics from those complexity measures, a number of benchmarks that should be selected for which complexity is assessed according to the mentioned criteria. For example, tasks as the following are good candidates. Adding a device to the network in the rudimentary configuration. Adding a device to the network in advanced configuration such as redundant failover configuration. Configuring all interfaces of the device with the same of the parameters. For example, this could be configuring all DSO ports, online cards for voice service with a certain in-hope convention setting. Configuration a loopback on an interface. Configuring an IPsec tunnel for an interface network topology. Adding a subscribe to a service. Clearly, it is possible for the different management applications to score quite differently when their duration of complexity is evaluated against the benchmarks. For example, consider the operational complexity that is involved in adding a subscribe to a service. An operation support environment that includes an application that offers cookie-cutter templates to facilitate this task will achieve a much better score than the operation support environment, which is a very aspect the device has to be configured individually, because more steps would need to be performed and more parameters would have to be remembered. Of course, we expected this outcome, but it is nice to have it backed up by quantifiable data. Related to metrics that intend to capture operational complexity for network managers are metrics that attempt to capture operational complexity for management applications. Instead of the number of the complexity of the individual operation steps, key indicators or number complexity of the communication exchange that need to take place. As before, it is advisable to select a number of benchmark tasks that are representative for task management application phase. Here are some examples. Keeping an application synchronized with the actual device configuration would mean the time between configuration changes 48 hours and maximum permissible time lag to reflect a change in configuration at 15 minutes. Collecting a set of performance counters periodically every 15 minutes over an interval of 24 hours. Running a diagnostic test pattern every 15 minutes over the period of 24 hours and being notified when an abnormal result occurs. Subsequently, the complexity of the changes between a managed network and a managed application is assessed. The number of communication exchanges that are required. The number of the dependencies between those exchanges, measured by the number of exchanges that need to be serialized as one of the exchange relies on a piece of the information provided by another. This also indicates the complexity of the rainy day scenarios in which things goes wrong and need to be recovered from. Again, different capabilities of the system agent will yield vastly different results. For example, those results show that to keep a management application synchronized with a managed device, a much lower number of communication exchanges is required when a reliable configuration exchange events are supported, compared to cases in which periodic sync up with devices is required.
Metrics for scale. Another aspect that is important to management effectiveness concerns scale. Scale is an area in which the need for metrics is widely recognized and often many different metrics are available. However, there are many excellent metrics for scale that are more appropriate. Here is a small example. Number 1. Time to provision 1,000 instances of a particular type of service. Number 2. Provisioning throughput, which is basically the inverse of the previous metric. Number of service instances that can be provisioned per time unit, which is minute per hour. Number 3. Time to synchronize management application with a network of a given size. Number 4. Number of events that can be sustained per second without dropping events. Number of managed devices of a given type or a given mix that are supported, accompanied by a meaningful performance measure. For example, while being able to perform a complete network audit within 60 minutes. Other metrics. Many other aspects contribute to management effectiveness. For example, one aspect concerns the effectiveness of events that are reported from the network and events that management applications bring to the network manager's attention. It is important that the reported event information be rich enough to convey what is going on, while focused and relevant enough not to distract from the real problems. One metric that is useful in this context is the number of observed alarms per root cause, effectively a management signal to management noise ratio. We would like to see this number go down, ideally to 1, in which case there is no noise and each alarm is indeed indicative of a distinct problem. In some cases, it might make sense to exclude events from the ratio that are explicitly used to report the impact of root cause and that to repair other events that point to the root cause. An example is service alarms that indicate how many customers are impacted by service outage, which is caused by failure that is indicated by a separate alarm. Another aspect concerns operational robustness and the error proneness of management interfaces. An interesting metric here is the percentage of network outages from operational error. This is the number that every network provider wants to see trend down over time. There are other aspects still, such as the consistency between management interfaces of different managed systems or between interfaces of management applications. As mentioned previously, the discussed metrics are by no means intended as a comprehensive list but an illustration of how the contribution of different factors to management effectiveness can be captured in a quantifiable manner. We leave this discussion at this point and turn to the topic of how to determine which metric should be applied in a particular situation. Developing your own management benchmark. By now, it should be clear that no single metric can be used to assess management effectiveness or the business contribution that management provides. Instead, many metrics should be looked at collectively to obtain the overall picture. Of course, it is possible to combine different metrics into one aggregate using some formula. In the end, the goal is to provide a set of criteria that can be used to assess the effectiveness and business contribution of management and management technology under different criteria. Because there are so many metrics, which one should use in your particular case? The answer is, it depends. Use common sense. Obviously, when assessing the effectiveness of fulfilling telephony service orders, as a metric to assess provisioning throughput will be more meaningful than a metric measures the capacity of processing alarms. To identify the meaningful metric, it helps to think about the properties that are most important in a particular context. For example, is the main concern cost or improve availability? Depending on the answer, focus on metrics that provide information on one versus the other and combine them into a management benchmark custom tailored to your specific situation. Also, be creative. Do not hesitate to invent your own metrics as needed. Usually, a good question to ask is, what use cases need to be assessed? Use case analysis is a software engineering technique that used to identify system requirements. In a nutshell, use case analysis works as follows. First, set of actors is identified. Actors are entities that derive value from the system being analyzed. Network operators. For example, then a set of basic scenarios called use cases is identified. For each use case, the individual steps and interactions that need to occur between the actors and the system are specified, along with preconditions and postconditions that are supposed to hold before and after the use case is executed, and an explanation of exceptions that can be occurred. Nothing prevents use cases from being used not only to derive requirements, but also to capture the factors that best characterize how effective the use case is executed. The result is a set of metrics that is custom tailored to a particular context. One way in which metrics can derive is to apply the complexity measures that were discussed earlier in the operational tasks that correspond to the use case. For example, it can be meaningful to compare different systems with regard to the number of steps that are required for a given use case, along with the complexity of information that needs to be exchanged at each step. Assessing and tracking the state of management. Now that we know that the types of metrics can be applied, what values should these metrics indicate? What constitutes a good or acceptable value versus one that is bad and needs improvement? The general answer is it depends. What is perhaps the most significant about those metrics is not their actual value at any one moment in time, but the fact that they can serve as a basis for quantifiable comparison. Those comparisons can be conducted between alternatives. For example, metrics can be used to compare management effectiveness between different service or IT departments, providing insights into their relative strengths and weaknesses. It might not be really all that interesting to know that it takes a service provider organization 8 hours to provision 1,000 instances of a particular type of service until you hear that it takes the competition only 15 minutes. Other metrics can be used to compare the effectiveness of different management applications and different device types and devices from different vendors that play similar role in the network. Comparison can only be conducted over time, allowing assessment of progress. Again, the absolute value of metrics is often lesser significance as long as it trend points in the right direction. If your ratio of customer reported incidents to incident overall stands this month at 20%, it might be good news. If it was 21% last month and 30% a year ago, because it means you have gotten better at identifying problems yourself before they impact customers. However, it is bad news if you used to over around 50%. Another aspect to consider is that no single metric tells the whole story, but many metrics combine to provide an overall picture. It is easy to get lost in the amount of data that can be collected. What can be extremely helpful in such situations is a way graphically visualize the data. No one common established technique exists for this. For example, metrics that relate to operator productivity are in one quadrant. Metrics related to availability and impact by management are in second quadrant. Metrics that relate to the integration task are a third quadrant, and so on. Then the value for each metric is assessed. The corresponding coordinates are connected and enclosed area is shaded. To compare different alternatives, the respective profiles can be superimposed to identify areas where over and underlap occur, exposing their respective strengths and weaknesses. As management effectiveness improves over time, the values of the coordinates increase and overall enclosed area grows. It is also possible to compile a single value across a set metric according to some formula. For example, each metric might be assigned a weight factor that is multiplied before being added up. Although this approach is easy to use and convey, one drawback is that some information is lost in the course and the resulting picture is less differentiated. Using metrics to direct management investment. Metrics such as those discussed in this chapter can be tremendous help when trying to determine where to direct management investment and to assess whether a particular management investment might even be worth the while. A general approach to take is as follows. In the beginning, establish the network objective for further investment. For example, is the most important goal to reduce operational costs or increase the network availability or to accelerate rollout of a particular service. Number 2. With the objectives in place, identify metrics that can be used to assess the degree to which those objectives are met. Number 3. With the metrics identified, determine different alternatives that will have an impact on those metrics. We saw many examples of this in the subsection on factors that determine management effectiveness. Assess and try to quantify the expected impact of those factors in terms of identified metrics. Finally, select the alternative that yields the most attractive return on investment or ROI, that is, the highest benefit in relation to the cost. Additional investment should be made as long as the expected ROI is deemed favorable. ROI is generally determined by dividing benefit expected from an investment by the investment amount. A related measure calculates the time until the benefit will have paid for the investment. In our case, the benefit may not always be expressed in terms of dollars. However, the same great general idea can be applied.